Hello friends, welcome to you. Now we are going to solve gate problems by relative instantaneous center method, and especially we will do it for slider crank mechanisms. This is a problem from GATE 2014. It has been asked that this is a slider crank mechanism, say O2AB. Length of O2A is 60 mm. Length of connecting rod, that is AB, is 240 mm, and the angle between crank and connecting rod is 90 degree. The angular speed of crank is 10 radian per second. It has been asked that what is the speed of slider. So say speed of slider is Vb. So you have to find out Vb. So how to find? If you apply the concept of relative instantaneous center, then we know the velocity of link 2, that is the crank. Let us denote fixed link as 1, crank as 2, connecting rod as 3 and slider as 4. So velocity of 2 is known to us. We have to find out velocity of link 4. So like our previous problem, here we have to locate the relative instantaneous center between 2 and 4, that is I24, because at I24 both link 2 and link 4 has same absolute velocity or zero relative velocity. So here are also 4 links, so there will be 6 relative instantaneous centers: I12, I13, I14, I23, I24 and I34. How to locate them I have already discussed in my previous lecture. That was, I think, lecture number 8 on relative instantaneous center. So by visualization we can directly locate I12, because O2 is I12, because O2 is the center of revolute pair and which connects link 1 and 2. A is I23 because A connects link 2 and link 3. B is what? B is I34 because B connects link 3 and 4. Where is I14? 4 is connected to 1, this is fixed link 1, by a prismatic pair, and 4 has a pure translation. So all points on 4 will have same velocity, and when a body has a pure translation, the relative instantaneous center I14 lies at infinity, and which is on a line which is perpendicular to the direction of B or direction of the slider. What is the direction of motion of slider? That is along O2B. This is the sliding path. If this is the sliding path, then the slider is constrained to move along this path only, and I14 lies on a line which is perpendicular to this line, that is the axis of the slider, at infinity, because 4 has pure translation. So we have located I12, I23, I34 and I14. Now, but our objective is to locate I24. How to locate I24? Similarly, like our previous problem, take link 2, 4 and 1. What are the instantaneous center between these 3 links? I12, I14, I24. Now here is one concept, that all parallel lines meet at infinity. All the parallel lines will meet at infinity. So we can consider that I14 also lie here. This is a line, I14 lies on this line also at infinity. Because all the parallel lines will meet at infinity, so we can consider that I14 lies on this line also at infinity. As all the lines meet at infinity, so we can shift I14 on all parallel lines which is parallel to this line, which are parallel to this line. So this line is also parallel to this line. So we can consider I14 lies on this line at infinity. Now which are collinear according to Kennedy's theorem? I12, I14, I24. So I12 is where? This is I12, O2. I14 also lies on this line. So I24 must lie on this dotted line. I24 is also lies on this dotted line. Now take link number 2, 4 and 3. What are the instantaneous centers? I23, I34 and I24. So these three relative instantaneous centers will also be collinear. Where is I23? This is I23 A. Where is I34? This is I34 B. And I24 will also lie on this line. If I extend this, this is intersecting at this point. And as I24 lies on this line and this line also, so this is the position of I24. Let me write here. This is I24. So we have located I24 here. Now the concept is what? Velocity of link 2 at I24 is equal with velocity of 4 at the point I24. The 2 has pure rotation about the hinge point O2. Link 2 has a pure rotation about the hinge point O2 and it has a angular speed of 10 radian per second. So what is the velocity of 2, V2, velocity of 2 at I24? That is what? Omega 2 into O2 I24. So velocity at I24 of link 2 is O2 I24, this is the distance, and 2 is hinged about O2, so it has a pure rotation about O2, so this is the velocity. Velocity of 2 at I24 is this. Now what will be the velocity of 4 at I24? Velocity of 4 I24, that is equal to what? Velocity of 4 at I24. This is a very important concept, that 4 has pure translation, and at pure translation all points on a rigid body has same velocity. At pure translation all points on a rigid body has same velocity. So if this is point B and that is on link number 4, so velocity of point B on link number 4 and velocity of I24 which is also at link number 4, we are considering that. So both will have same velocity. So velocity of 4 at 24 will also be Vv, because all point on link 4 has same velocity. Because at pure translation all point on a rigid body has same velocity. So this is Vv. So if we can find this, that will be equal with Vv. Now how to find this length O2 I24? This we can calculate from simple geometry. Let us consider this angle is theta. This is 90 degree. So what will be crank angle? Crank angle will be 90 degree minus theta. If you subtract these two from 180 degree, it will come 90 minus theta. Now this is perpendicular to the horizontal line, so this will be also theta. So angle AO2 I24 is also theta. Now we can apply theta by sine law or using Lami's theorem, that is length of AB and O2A is known. So O2A by sine of theta is equal to AB by, sorry, this angle is known, or you can find it by sine theta. No, sorry, tan of theta. Tan of theta equal to what? This is the perpendicular, so this length is 60 divided by 240, and theta will come 14.03 degree. Let us calculate that this angle will come 14.03 degree. So now we have to find O2 I24. If theta is 14.03 degree, then let us find, we have to find O2 I24. Come to here. O2 I24 is equal to what? This length, that is nothing but O2A by cos of theta. So O2A is 16, so this is 60 by cos 14.03 degree. Now put it here. VB is equal to what? Omega 2, that is 10 into 60, that is in millimeter. So if I convert it into meter, then it will come 0.06 divided by cos 14.03 degree. So it will becomes how much? Let us calculate it. It will come 0.619 meter per second. So this 60 was in millimeter, we have converted it into meter, that is 0.06. So this is the answer. This is the sliding velocity of the slider. Now we have done it and we got same result as we have find it in by relative velocity method in lecture number 9. Now if somebody asked to find out what is the angular velocity of AB, what we will do? You will locate I13. You will locate what? I13. I am telling you the significance of I13. Extend this line and this line, you will get the intersection at I13 that I have discussed in lecture number 8. Now I13 is what? Relative instantaneous center of 3 with respect to 1, and 1 is a fixed link. So I13, when one of the link is the fixed link, so I13 is nothing but the absolute instantaneous center of 3. So if you get absolute instantaneous center of 3 and velocity of point B and A both are known, so divide that distance by velocity by divide that distance, you will get the angular speed of AB. So we have completed this problem that asks to find out the sliding velocity. Now we will solve another problem. And this problem is from GATE 2017. It has been asked that the same problem, but the orientation of links are different. Here O2A B. O2A is what? O2A is here 100 mm and AB is 160 mm, and omega 2 is equal to 10 radian per second. Here also you have to find the sliding velocity of the slider, that is Vb. What is Vb? Here also Vb is restricted, the motion of B is restricted along the axis of the slider, so Vb will be along this direction. Let us denote the link numbers. Fixed link is by 1, crank is by 2, connecting rod 3 and slider is 4. So here also you have to locate I24. Now as we have already done in the previous problem, we will locate I24 directly. Where will be I24? I24 is intersection of perpendicular line from O2 here, which is nothing but O2A and AB. So A is nothing but I24, 24 comma I23. So at this instant I23 and I24 locates at the same position. So at point A, link 2, 3 and 4 has same velocity. So what is the significance of this? That I24 and I23 are lies on same point A. So I24 means 2 and 4 have same velocity at A, and I23 means 2 and 3 have same velocity at A. So at point A, link 2, 3 and 4 have same velocity. So what is velocity of link 2 at A? So V2 at A, that is nothing but I24. So point A is the location of I24. So what is the velocity? That is omega 2 into O2A. And this is equal to what? V4 at I24 or A. So as 4 has pure translation, so all point on link number 4 has same velocity. So V4 at 24 is nothing but Vb. If point B has velocity Vb, then all point on 4 will have same velocity. So what is the velocity of Vb? Omega 2 is 10 radian per second and O2A is 100 mm, that is 0.1 meter, that is equal to Vb. So Vb becomes 1 meter per second. So this is the answer, and we got the same answer by relative velocity method. Now one question, one more analysis we are doing for ourselves, that is at this condition what is the angular velocity of AB. So we have done it. So let us erase these things. We have already done this problem. So let us erase. Now I am asking you, what is the omega AB is nothing but omega 3. Let us calculate what is the angular speed of the connecting rod. So at this instant, what is the location of I13? I13 is what? If we extend this perpendicular line and we will extend the crank, the intersection between this perpendicular line and the crank is the location of I13 as we have located in lecture number 8. Please go through my lecture number 8 where we have already located I13. But here both the lines are parallel and all parallel lines meet at infinity. All parallel lines meet at infinity. So at this instant I13 is at infinity. And I13 means one is a fixed link, one is fixed. So I13 means this is nothing but absolute instantaneous center of link 3, because relative instantaneous center with respect to a fixed link means that is the absolute instantaneous center of 3 and which lies at infinity. When absolute instantaneous center lies at infinity? When 3 has a pure translation. When 3 has pure translation. So when pure translation, so omega 3 becomes 0. That means at this instant the link AB has pure translation and relative angular velocity of link 3 is 0. So when the crank is perpendicular to the fixed link, then the angular velocity of the connecting rod becomes 0. Thank you for watching this video. Hope you have understand. Best of luck in your GATE examination. Jai Hind.